This section of the tutorial demonstrates one of the more advanced capabilities of Trident, namely using a feature vector in a storage class definition to provision a volume across heterogeneous backends. Now let's look at a more complex definition of a storage class. I'm going to define a storage class called bronze. The provision for storage class bronze is again Trident. And any backend whose media type is hard disk drive can support thin provisioning and can support snapshots, as well as the SolidFire backend that I just added can be used to provision volumes of type bronze. So this basically means any of my three backends are candidates for provisioning volumes of type bronze. And in this case, Trident would randomly pick from one of the three. So let's create a storage class called bronze. Again, this is done by the storage admin. So there should be now three storage classes in my cluster. We can check that Trident successfully added the new storage class. And here we see that there are three storage pools that satisfy storage class bronze. If you want to know exactly what those three storage pools are, we can use Trident's REST API to get that information. So here I'm using Trident's REST API. As you see, there are three storage classes here that match the three storage classes defined in the Kubernetes environment. So if I want to get more information about the bronze storage class, let me use the JSON output. So here we see that the three storage pools that are going to be used by Trident for the bronze storage class are ONTAP SAN, Agar 1, the SolidFire bronze QoS span, and the ONTAP NAS Agar 1 storage pool. So if I want to provision a volume of type bronze, the user would come and create a PVC that references the bronze storage class, and here we have other attributes such as the volume size and the access mode for the volume. So by creating this PVC, we see that Trident creates a PV for it on the fly. We can describe the PV to see what backend Trident used for this PVC. In this instance, we see that Trident used the ONTAP SAN storage virtual machine for provisioning the bronze volume. So if I go to another wall show, we see that for the iSCSI storage virtual machine, we have a new volume that corresponds to the bronze PVC that the user defined. So if you recall, in the storage class bronze, we define a set of attributes for the backends that would be considered for storage class bronze. So here we see that backends whose media type is of type hard disk drive can support thin provisioning, can support snapshots, as well as the bronze QoS band of the specific SolidFire backend would be used for provisioning volumes of type bronze. To know exactly what capabilities of a given backend are, we can use Trident's REST API. So if I, for example, want to know what are the capabilities of this NAS backend, I can use this command to see what capabilities are supported by the NAS backend. So here I see that this backend's driver type is ONTAP NAS. So if you specify ONTAP NAS driver or for the backend type in your storage class, this backend would be used. Its media type is hard disk drive. The possible values are hybrid for hybrid aggregates or SSDs for all-flash ONTAP systems. It supports snapshots and it supports both thick and thin provisioning. So based on what attributes a given backend supports and what attributes you specify in your storage class definition, Trident matches these storage classes to storage backends that it manages. If you're interested to learn more about Trident, please visit the project page on GitHub. You can find more information about storage support in Kubernetes by following the links here. Finally, if you have any questions about Trident, please reach out to us at netapp.io Slack channel for containers. Thank you very much.